Hello everyone. In this video I'm going to solve a set of linear equations, two linear equations in two variables, and our key focus is to see under what conditions you get one unique solution of x and y, or no solutions at all, or there are many solutions, and what are their geographical or visual implications, how we can understand it in graphical format. So first of all, let's get started and solve this first equation. The way we could solve is simple. We can use the elimination method. So we subtract this first equation with the second one. From the first equation we subtract the second equation. This becomes plus, this becomes minus. 2x minus x is x, and 7 minus 3 is equal to 4. Substitute the value of x in, let's say, the second equation. So 4 minus y is equal to 3, and this will mean that y is equal to, y goes here, x goes here, so y becomes 4 minus 3 equal to 1. Now what this unique solution means, and then let's solve this equation. And the way we can try to solve this is by multiplying, trying to eliminate y from these equations. So if I try this way, what happens is, if you multiply this equation by 3 and multiply this equation by 2, trying to eliminate these things, we get minus 4y, and this plus 6y becomes 0. At the same time, when you multiply 4 with 3, it becomes 12x here, and 6 into 2 minus 12. So this becomes 0 and this becomes 0. At the same time, we have 5 into 3, 15, plus 2 is 17. It is giving out an equation 0 equal to 17, which means that this equation has no solution. So what is having a unique solution and no solution has to do? So what we'll do is we'll plot a graph of these two lines and see how they look like. The first one, let's say x minus y equal to 3, I can write it as y equal to x minus 3. And if I try to plot these things in the standard y equal to mx plus c format, we see that it has a gradient of 45 degree and y-intercept as minus 3. So the line is going to look like something like this. Now the first equation, 2x minus y, I can write it as 2x minus 7, has a y-intercept of somewhere minus 7, but it has a gradient which is twice this much, so maybe this equation will look something like this. So one thing we could see is that this has a gradient of 1 and this one has a gradient of 2, m2 and m1. What we find is that if m1 and m2 are unequal, the lines are not going to be parallel and they have to cut at some point. So that is when you get this one unique solution, if these two straight lines. So m1 is not equal to m2, and in that case you get one unique solution. Let's take a look at the second one. In the second one, we have the equations. So the first one says, if I write it in a way where y equal to, I can write y equal to, this is 2x, and then 5 divided by 2 plus 5 by 2. That is equation number 1. You can rearrange this. 2y take this side, 5 to this side, becomes, actually this 5 becomes minus 5 by 2. So I write minus 5 by 2. Want to make sure I'm not making any grammatical mistakes. Okay, somehow I lost the thing, but I'll rewrite. So I'm plotting the second equation. Okay, so the second equation, let's rewrite this. 2y equal to 4x minus 5, or y equal to 2x minus 5 by 2, and this one I can write 3y equal to 3y equal to 6x plus 1. So y equal to 2x minus 1. So this is equation number 1 and this is equation number 2. And how do I plot these graphs? Again, the first one has a gradient of 2 and y-intercept of minus 5 by 2, minus 2.5. So this equation may look something like this, cutting it at 5 by 2 or 2.5. Now this one has an intercept of minus 1, but this one has the same gradient, which means that this line, this is the line number 1, y equal to 2x minus 5 by 2, and this line is y equal to 2x minus 1. These lines are parallel. They are not going to intersect at any point in this one, and therefore this will have no solution. Now remember, there are many ways of visualizing when these two lines will not have any solution. This is one way we are used to, where we write the lines in the form of the gradient form, y equal to mx plus c. But if you closely look at this particular thing, it also happens when the ratio of the x coordinate to the y coordinate is same, which means if this is, let's say, a1x plus b1y equal to c1 and a2x plus b2y is equal to c2, then this is going to be same even if a1 by a2 is equal to b1 by b2. We can also say a1 upon b1 is equal to a2 upon b2. Actually, this a1 by b1, actually b1 by a1 gives kind of the gradient. Minus a1 by b1 is the gradient of this, and minus a2 by t2 is the gradient of this. So if a1 by b1 is same as a2 by b2, this is same. If you rearrange these things, you can also that if a1 by a2 and b1 by d2 are same, then also these lines will have solution. There's another way where AI engineers see is that if a1 a2 is a a1 b1 is a linear combination of a2 b2, in that case also these two equations will not have any solutions. So these are the way you visually can feel about it. And let's take a look at the third equation. The third equation is 2x minus 4y equal to 10 and 3x minus 6y equal to 15. Usual way when we will try to solve this equation will be by trying to eliminate y, and in that case you multiply this equation. Let's try to eliminate x, looking like a smaller number. So I multiply this equation by 3 and multiply this equation by 2. So 2 into 3 becomes 6x, 3 into 2 becomes 6x. They cancel out, but what happens here? 4 into 3 is 12 and 6 into 2 is also 12. So this becomes 0, this becomes 0. And now let's take a look at the right hand side. 10 into 3 is 30 and 15 into 2 is 30. So this becomes also 0. The equation becomes 0 is equal to 0. In that case, we have many solutions. Many solutions of x and y will satisfy this equation. But not any random value of x and y will solve. They still need to follow some rules. And what those rules are? Those rules are, let's take one of these equations, 2x minus 4y equal to 10. We can simplify it a little bit. Write x minus 2y equal to 5. If if equal to lambda is one solution, then I substitute in lambda. I get the value of x as 2 lambda plus 5. So all the solutions must comply in this format. So the x coordinate must be 2 times the y coordinate plus 5. You could also write in other different formats, but they still need to comply these things. Now, what I'm going to do is take a look at what is the visual implications of these things, and I draw again an x coordinate and a y coordinate, and I'm trying to write these equations again in a format. Let's say the first one is 2x minus 4y is equal to 10, and then we'll try to write this equation in y equal to mx plus c format. You realize that this equation is 4y equal to 2x minus 10, and if I try to write in y equal to mx plus c format, it's going to be 1 upon 2x minus 5 by 2. And let's try to do the same thing for this one. So we have 6y equal to 3x minus 15, okay, and then y is equal to 3 by 6 is half x in minus 15 by 6 divided by 3, so this is 5 by 2. Now what's happening here? Let's take a look at their gradient. Both of them has a gradient half x, and what's the x y intercept here? So 1 by x is something like this, and y intercept is minus 1 by 2. So this is the line number 1 with gradient m equal to 1 by 2. Now the second line has the same gradient. This is parallel to this line, but it's different from this case where this line is the same as over this line, because their x intercept is also y intercept is also same. So L1 as well as this L2 line shown as dotted, both of the lines overlap each other, and therefore any point on this line is going to be a solution of this equation. So we have infinitely many solutions. At the same time, the points on any other line are not going to be the solutions of this equation. So many solutions means there are infinite solutions. But for example, if this line has infinite solution, but these infinite solutions are not these infinite solutions of these lines. So this is how we see solving linear equations. It's used in your SAT exams, for example, but this also is going to be useful for your linear algebra course in AI math courses. Thanks for watching.